Hello, everyone, and thank you for joining this session today. So we're going to be discussing GitGuardian's State of Secret SPRAWL report for 2022. Now, this report isn't one that we do annually, and we look at all the secrets that have been leaked during the previous year, so in this case, 2021. And so just to get an idea of how the session is going to work, we actually expanded our report a lot since previous years. So if you've reviewed the report in 2021, we really focused on public GitHub activity. So the secrets that we found when scanning public GitHub repositories. But now we're expanding this a little bit, and we're including other public elements such as Docker images, and we're also including some analysis from private repositories and how they compare. So it's going to be very interesting. We're going to run through each of those different segments. So public repositories, Docker images, and internal repositories. And then we'll have a little bit of a wrap up and a recap. And then finally, there's going to be an opportunity to ask some questions directly. So that will be the format of today. A little bit more about what is the State of Secret SPRAWL report. As I said, it's an annual report that GitGuardian does, and it looks at all the different types of secrets that are leaked and provides analysis on them. So we're not just looking at the number of secrets that were leaked publicly, but we're also going to provide insights into where those secrets were leaked, what files they were, some common ways in which they do get leaked, and then other analysis such as the types of keys and the countries in which they leak from. So just before we go too far down, I would like to share some definitions just so that we're all on the same page so that the report makes sense to everyone. So first of all, we need to look at what is a secret. So when we're talking about secrets, what we're referring to is digital authentication credentials. Now, typically, these are things like your API keys, your credential pairs, security certificates, really anything that provides us access or authenticates us into systems and services. The other main one is, when we're talking about secret sprawl. And secret sprawl is really when we've lost track of these secrets. These are very sensitive information, and we want to make sure that we protect these secrets and keep them tightly wrapped in lots of authentication. And secret sprawl is when we lose track of those secrets, when we no longer have visibility over where they've ended up. And you can imagine the secrets sprawling through different systems and repositories. So I want to also touch on a little bit before we get the results on some of the methodology that we use to find these secrets and detect them. So GitGuardian has a very powerful detection engine, but it goes through a number of different steps to be able to detect these secrets with a high amount of accuracy. So we have two main methods of detecting secrets. The first one is that we use what we call specific detectors. Now, these specific detectors are really for specific types of keys. So we have currently 350 different types of these detectors, and you'll have a specific detector that's only looking for AWS keys, Google Maps keys, Mongo database credential pairs, everything very specific. And this allows us to really tune into what we're looking for in that specific secret. It means that we can really reduce the amount of false positives that we have. Now, the other method of detecting secrets is what we call generic detectors. And this is something that's very unique to GitGuardian. And that is that we use different methods of detecting what we think could be secrets, but may not fall under that specific category. For instance, passwords. They're very hard to specifically find a password for a certain system. So they fall under the generic detection capabilities. Or it could be a private key for an internal system. So obviously, we don't know all of the private systems that may have, so it's hard to detect secrets on these using specific detectors, but can detect them using generic detectors. So this is quite powerful because it means that we have a much wider net when it comes to capturing these secrets. But with the generic detectors, we also are able to apply a lot of weak signals and look further into the files and the repositories to really validate that it's a true secret. Because if we didn't take that step, we would end up with a lot of false positives. So there are two methods that we use to detect secrets. And the other area that I want to talk about is the validation process. So one thing that GitGuardian does is we actually validate with the providers if the keys are active. So if we find an AWS key or Alibaba cloud key, then we will validate those to make sure that not only are they actual keys, but they're currently active. So this means that the results that we get are very, very specific and with a high level of accuracy, because when we're able to, we validate the secrets that we find. But that's not the case for all secrets. For instance, we don't validate generic detectors because we don't know what system they're coming from. So that's a little bit of the methodology that we use to be able to find these secrets. So to start with, I want to talk about public monitoring. Public monitoring is us looking in public GitHub, the commits that are made publicly to GitHub, and trying to find if there's secrets in there. Now, GitGuardian actually scans every single public commit that is made to GitHub throughout the entire year. So to get an idea of scale, this is well over 1 billion commits that are made, and GitGuardian scans every single one of those for secrets. And when we find them, we alert the user, or if we can, of that GitHub repository that they've leaked a secret. And then we are also able to present that in a report like this. But that is how our public monitoring works. So I just want to pose just a silent question here is, how many secrets do you think were leaked in 2021? Just as a recap, 2021's Secret SPRAWL report, so looking at 2020, we discovered just about 2 million secrets, which was a 20% increase from the previous year. So have a think. How many do you think were leaked this year? Less than 2 million? Do you think we saw an improvement? 2 to 3 million, roughly a 20% increase again. 3 to 5 million, a big increase, or 5 to 6 million, a massive increase in secrets. So before I tell you the answer to this, just a quick recap of last year's State of Secret SPRAWL report. So as I said, we found 2 million secrets that were leaked in 2020. We scanned over 1 billion repositories that year, and it was a 20% increase to the year before. So what we found in public GitHub this year is actually 6 million secrets were discovered throughout 2021. And we calculate that to be about a 100% or a 2x increase. Now, if you're wondering why last year we discovered 2 million, this year we discovered 6 million, yet we're saying that only a 100% increase, 2 plus 2 doesn't equal 6. That is because when we're doing a fair comparison, we get about a 2x increase. And that's because we've increased the number of detectors from 250 to 350. So we have much wider detection capabilities. And we've also seen about a 25% increase in the amount of code committed. So when you factor in those together, we get about a 100% increase, which is still a massive increase in the amount of secrets that have been committed. So looking over to the right of my screen, as I said, we've seen about 25% increase in the amount of repositories that were created last year. And we've also seen about a 23% increase in the amount of commits that were scanned. So what really that means is that the number of repositories has obviously increased, but the number of code that is pushed has increased slightly less than the number of repositories. But we can see that these are very closely aligned numbers. So looking now at the type of secrets that we've discovered. So we've broken it down into some categories. Obviously, with so many different types of detectors, we can't kind of provide an easy readable graph on all of them. But if we break it down into some categories, for instance, data storage was about 21%. So obviously, these refer to database credentials that were leaked. Cloud providers were about 15.2% increase. So AWS, Alibaba, Azure, these types of keys. These are the highly sensitive keys. Private keys was about 9.5%. Development tools was also about 9.5%. So development tools would be Django keys that work to the inner workings of your application. Messaging systems is an interesting one, which is about 8.5% of what we found last year were in messaging systems. And then finally, about 1.5% were version control systems. And the main category is what we're calling other. Now, other is kind of those generic detectors that we don't know. And this year, we've about 32% were in that other category. Now, if we compare that to last year, the lighter color on my screen is the results from last year. And we can see that we've seen a massive increase in the other category. And this is because of the improvements that we did with our generic detectors. So that explains why a lot of the system, where a lot of the other categories went down. But we've also seen a drop in messaging systems, the types of keys in messaging systems. And we hypothesize that this is really because of a lot of awareness around the sensitivities of these types of keys. So some other interesting areas we found secrets. We found over 500 commit messages that contained GitHub credentials. So it was your personal access token to GitHub. We found 500 commits that had this in the commit title or the commit message. So this is a really quite a staggering thing. I think what this shows is there's still a large misunderstanding of even how Git works, that we can't quite figure out why someone would put their access token in their commit message, but it obviously does happen. So this was quite a shocking result to us, but it shows that there's still a lot of kind of misunderstanding in how Git works and how we authenticate ourselves into GitHub. And this is obviously a high value target for attackers. If attackers can gain access to your personal GitHub credential, then they can move into your account, they can inject code. And because you can use a personal account on GitHub for both private, from both your organization's work and your personal work, then an attacker can move into your organization's repositories through you leaking your personal access token. So this was quite a scary discovery that we found here. Now, we do have some slightly good news from this. There has been some positives this year. Obviously, there were huge increases in the number of secrets we found. But when we look specifically at a couple of types of secrets, we can see a reduction, although slight reduction in the amount that we find. So for example, AWS, with a fairly substantial reduction in the amount of AWS keys that we found throughout the year. So this isn't because AWS has become less popular. In fact, they've increased their popularity, but this is because there has been a lot of effort to really focus on how sensitive AWS keys are by a lot of parties, including AWS themselves. So this has meant that we are winning a battle of education in really understanding that these keys are sensitive and shouldn't be made public or need to be protected. So this shows that education does work. It shows that we can reduce the number of leaked secrets, but it also shows the amount of effort that it's really needed to take, because this was really the only key this year that we saw a significant reduction in. The other types of cloud provider keys, we've seen Alibaba keys have also had a reduction throughout the year. And then we will look at some of the newer players and how they look in the coming year. So obviously, when we're talking about cloud infrastructure, we obviously know AWS, we know probably Azure or Google Cloud or Alibaba, but actually there's been some new players come into the market, and it's been interesting to see their evolution based on the amount of secrets that we find. So for example, PlanetScale and Supabase, you can see them here, going from almost no secrets leaked at the beginning of the year to the end of the year having quite a significant amount of secrets coming out. We can see that there's increase in popularity. Now, this shows us a couple of things. One, that the market is expanding. There are more solutions coming out, but it also shows that we absolutely need ahead of the curve in secrets detection to be able to secure our repositories. We need to be making sure that we're able to detect these secrets, before they become popular. And this is why having generic detectors GitGuardian is so popular. But it is great to see that there are other companies coming out in there, although not so great that we can measure that based on the amount of access credentials that are leaked for them. All right, I have another question here of something that I always find quite amusing to ask people. So have a think to yourself, when do you think most of the secrets will be leaked? So, Monday, as you're tired from the weekend. Wednesday, it's the middle of the week, so it's difficult. Friday, because you're maybe looking forward to the weekend. And of course, on weekends, maybe working on a personal project, or perhaps there's no clear data on this. So have a think, when do you think that the most amount of secrets in this case would be leaked? So Mondays, Wednesdays, Fridays, or weekends, or no clear data. And what we actually found is that most leaks actually happen on the weekends. So we kind of hypothesized from this that this is because people are working more on personal projects on the weekend, so more likely to be pushing code to public repositories. So this makes sense. But we also have to bear in mind that we find a lot of corporate credentials in personal public repositories. So this means that even on weekends, we have to be very careful and very vigilant over what employees and developers are actually pushing. And if we exclude weekends, the next most popular days for leaks to happen on public holidays. So again, this fits in with the same hypothesis that it's actually the days that you're working mostly on your personal projects that you're most likely to leak these credentials. So now I want to change it up a little bit, and I want to stop talking about public monitoring for a minute, and I want to talk about scanning your Docker images. So DockerHub, or DockerHub.com, is the Docker equivalent to GitHub. It's a place where you can publicly store your Docker images and allow people to retrieve them. So this year, GitGuardian started scanning Docker images to create a similar kind of analysis. Now, in total, we scanned 10,000 Docker images. So unlike GitHub, we don't scan every Docker image that is pushed into there, but we did scan about 10,000 this year. And for comparison, there's about 8.8 million Docker images publicly available. And looking in that 10,000 Docker images, we found about 4.6% of them contained at least one secret. So this is another huge issue that we are facing, because now we have these additional technologies that we also need to be, focused on, making sure that our Docker images, companies that we use, or the Docker images of our employees don't also contain secrets. So out of the 10,000 images that we scanned, we uncovered 4,000 secrets, and 1.2 thousand of them were unique. And I also have down the bottom here that we found about 6 secrets for every 100 layers. So a Docker image is built up of different layers. You can think of this like a Git commit, the kind of Docker equivalent. So you may commit a secret in one, or you may add a secret in one layer and remove it later on, but that secret is still exposed. So this is why we chose this analysis, is that every 100 layers, we find about 6 secrets, which is quite a significant amount. Adversary doesn't have to go digging too far to be able to uncover some secrets if they want to. Now, I want to talk also just very quickly about countries that leaked the most amount of secrets. So this is all public data, so your repositories and the Docker images. And we actually found that, same as last year, India leaked the most amount of secrets, followed by the USA, Germany, and France. So there was definitely some changes in these, but I think more what this data shows is the engineering that's happening in those countries. So there's a lot more software engineers in India. So we can see that these are increasing. I don't necessarily think that this is a bad thing, or that India is particularly bad at leaking secrets. I feel that this data just reflects these countries are growing in their engineering populations. And it's also great to see countries like Nigeria, Bangladesh, and Brazil actually kind of appear on this, because it's showing that the engineering populations, are kind of increasing in these areas. So I don't necessarily think that this is a bad thing, but it is still interesting data that we can pull out of the report. Okay, so next I want to talk about internal monitoring. This is the private repositories. So obviously GitGuardian is a service that scans internal repositories to uncover secrets. And so we've been able to pull some analysis using some of the customers that we have to understand the types of secrets that are being leaked in these internal repositories, so encrypted or password protected repositories. So we have some big numbers here. The first one that I want to talk about is that when we take a typically, a fairly large company with 400 developers, what we would find is that there is typically be 4 application security engineers in that company. And on average, we've found about 1,050 leaked secrets in a company this size. So that is a huge amount of secrets, just 4 people to actually have to go through, because they have to discover these secrets, find who leaked them, remediate them. And also, because each of these secrets has multiple occurrences, our analysis showed that each AppSec engineer has to deal with about 3,400 secret occurrences. That's 3,400 times each year that they have to investigate if a secret was leaked, investigate what that secret was, investigate if that is an active secret, does it give access to critical infrastructure, they have to revoke that, and then they have to replace that secret. So they have to do this 3,400 times a year, which, is nearly 10 times a day if you work on weekends. So this proves just how under-resourced we are in our application security teams and our security teams at whole. There is so much information that our application security engineers need to go through that it is kind of a losing battle, like pushing a boulder up a hill and then letting it roll down the minute you stop. So we need to fundamentally change how we think about security, because it is simply not possible to be able to deal with this many secret occurrences just for a couple of engineers. So this is why at GitGuardian, we're really advocating of the shift left methodology, which is all about bringing security more to the left and allowing developers themselves to be part of the security process. And we can do this by, having tools that help detect secrets before they enter your repositories, such as pre-commit hooks. We can do this in ways such as we have what we call the developer in the loop feature, which is when secrets are leaked, we loop in the developer that leaked that secret so that they can be part of that remediation process, so that the AppSec engineers can move quickly when they have to do this 3,400 times every year. So I want to now just have a look at, like the internal versus public. And what's interesting here is that we actually see, very strong correlation between secrets that are leaked internally and secrets that are leaked publicly. So when we're looking at the companies here, when secrets are being leaked internally, it drastically increases the likelihood that they will be leaked publicly as well. So this goes to show that when we're dealing with internal repositories, we have to apply the same amount of care as if they were public, because the likelihood of that code being leaked, I'm sure everyone is aware that code is a leaky asset. So the likelihood of that code being leaked to being made public, increases, when secrets are buried in there. So we have to be very careful when we're dealing with our internal repositories. So we have to move away from the idea that just because internal repositories are secure or protected, that it doesn't pose a very significant risk. So how do we start to solve the problem of secret sprawl? Well, we need to start by, as I said, shifting left, bringing security earlier on, and allowing developers to kind of have the tools to be able to be part of the solution. So we need to be able to try and detect secrets before they enter into our repositories, both internally and public. And we can do this with commit hooks, Git hooks. We'll scan our Git commits before they are pushed to make sure that they don't contain secrets. We need to progressively enable those pre-receive on our repositories to really block anything that slips through that chain, and make sure that we have protection on our repositories that can reject pull requests if they contain secrets. We need to be able to kind of really drastically increase the education in developers to help them understand. Now, we saw with the AWS keys that a big campaign of education has really reduced the number of secret occurrences of this key. So we need to maintain that, but do it broadly throughout, understanding that all secrets can be potentially very sensitive. And we also need to implement a long-term strategy that includes being able to scan our repositories in real time and historically. So Git is very unique in the sense that it is our entire history of projects that need to be scanned, because unlike other vulnerabilities, if we leak a secret early on in the project and commit over it, it can still present a risk. It can still present a vulnerability. So we need to make sure that we have a long-term strategy in place that will first scan our entire repository so that we can start with a clean base, and then stop the bleeding and scan in real time to make sure that when secrets do inevitably leak into sensitive places, we're able to stop them. So just a quick look at how all of that works. Here we have the kind of process going through of when a developer first makes changes to an application, commits them, and all the way to the end. So we can detect secrets at multiple stages of this process. For instance, we can detect secrets when the developer makes a commit before it's kind of put in the commit stash. And this enables the developer to be able to remediate quickly, get rid of that secret, and then seek how to handle that secret correctly. We can detect these changes on a pre-push level. So this is after a commit has been made, but before it's pushed to the repository. And again, this falls under the responsibility of the developer, and it provides them the tools and the power to be able to kind of take security into their own hands. And if we can detect secrets here, then we can actively reduce the amount of work that AppSec engineers have to go through. So in the case studies that we have done, large organizations, we have seen around about an 80% decrease in the amount of secrets that have made it to the internal repositories of those organizations by implementing these pre-commit and pre-push strategies, allowing that are controlled by the developers. So this means that we've reduced the amount of work by 80% for AppSec engineers when we're looking solely at kind of leaked secrets. And then the other area is that, okay, we need to empower developers, yes, but our security teams also need to know when secrets have been leaked and need to follow up on how these have been remediated, etc. And so this is where the other GitGuardian tools comes in place, because we are able to scan in real time repositories. AppSec engineers can remediate these issues effectively through a dashboard, but hopefully if the whole stage has been implemented, the amount of remediation that they need to do has been reduced. So this is kind of how we can look at solving this problem on a flowchart throughout the whole process involving multiple different members. And I think it's important to say that it's not just the responsibility of one person or one tool to do this. It's a holistic responsibility that's going to involve multiple stakeholders, multiple tools, and also education and processes. Okay, so that concludes the presentation for today. I am available at the moment for if you have any questions that you may have. I look forward to hearing from them.